Standards identified in these activities have been adopted from the content standards of the national organization for each discipline. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 8th grade science class have learned basic weather concepts such as relative humidity, barometric pressure, cloud formation, wind speed, and weather fronts. The students then work in pairs to create weather prediction models using Model-It software. Model-It software lets the students show the cause and effect relationships among the variables that affect weather. This learning activity integrates Science Standard A1 for grades 5 through 8, which requires that students develop the abilities to do scientific inquiry. It also addresses Science Standard E1 for grades 5 through 8, which requires that students develop the abilities of technological design.
Okay, what's the purpose behind Model-It? Who can remember that? Who can tell me? Corey?
So that we can kind of brainstorm all we know about the subject and put it on, and like put it all down on model building.
And their relationships.
And have the different relationships, and so we can see hands-on stuff.
So you can create your own models and show the interaction between the different objects in nature, how they affect one another, so the relationships. Alex?
I think it's supposed to help you think about relationships more too. So like even when you don't have the Model-It, you can still think this affects that.
Right. This affects, yeah, right. So you can do that without Model-It. What does Model-It though provide for you?
Well, you have control of the direct or indirect relationships.
Yeah, you can modify all the variables right there.
And you can see how it will change.
Without having to imagine it, it shows you.
Great. Without imagining it or waiting for it to happen, you can show how it should happen. So you could possibly predict.
Okay, let's actually try and figure out a way we can actually explain this.
Doesn't the time of day affect the temperature?
Yeah.
So we should have a relationship between
in the morning, the temperature is low. In the afternoon, the temperature is weak. And at night, it's high.
Okay, time of day affects the sunlight because there's sunlight in the.
Yeah, but it already is
high. And then when the sunlight, it gets hotter when the temperature goes up, and when the temperature goes up, the chance of rain goes up. Wait, no.
Surely.
Goes down.
No, not necessarily.
Yes, because when
there's no bearing on the temperature. There's no bearing with the temperature. No, wouldn't it be the other way when the temperature increases?
Yes, because when it gets colder, relative humidity goes up, and when relative humidity goes up.
And to G weather.
So should we start by
G weather Model-It?
See the temperature goes there, and once the relative humidity goes down, the chance of rain goes up.
That's about clouds.
So it does or does not make sense?
It makes.
Okay,
G
but
weather
huge holes
it's in
thing, but that's
So should we make the relationship between these two?
When there's lack of clouds.
Oh yeah, let's put it in.
It's not here either.
No, there's already a relationship.
You mean it's not on the desktop?
Between time of day and temperature?
Yeah, because time of day,
Oh,
there's
yeah.
more sunlight, and when there's more sunlight, it goes to temperature.
Just transfer it over.
Sunlight decreases by.
One sec.
As the students use Model-It to create their weather prediction models, they also implement Technology Performance Indicator number 8 for grades 9 through 12, which requires that students select and apply technology tools for research, information analysis, problem solving, and decision making in content learning. Before the students present their weather prediction models to their classmates, the teacher engages the students in a discussion about the nature of scientific knowledge. The discussion helps the students understand the laws that govern the universe and the role that model building plays in helping scientists understand them. This learning activity integrates Science Standard G2 for grades 9 through 12, which requires that students develop an understanding of the nature of scientific knowledge.
I have a couple questions about models. Someone mentioned that the good thing about models is that instead of trying to imagine what might happen, once we have it in place, that we could play with it and change the variables to help us predict what might happen, okay? Plus, aren't there a lot of things out in nature and in science that we couldn't possibly explain or have come up with explanations for how things happen if we didn't have models, right? For instance, to find out if we have a heliocentric world instead of a geocentric universe, right? So that we move around the sun instead of the sun moving around us. And there are models that scientists use to show you what types of facts are certainly answered by the models, and what might be the one phenomenon that doesn't work when it's a geocentric world as opposed to a heliocentric world. So models certainly help us, and they can be changed. So for the way the conditions are right now, this is the way these things work.
The students present their weather prediction models to their classmates. This learning activity integrates Technology Performance Indicator number 10 for grades 9 through 12, which requires that students collaborate with peers, experts, and others to contribute to a content-related knowledge base by using technology to compile, synthesize, produce, and disseminate information, models, and other creative works.
In our model, we made it so if you have high pressure...
You have to speak louder, hon.
If you have high pressure, the pressure goes high, and then also the precipitation goes up higher. I mean, goes lower because and the clouds go lower because in high pressure you can't have clouds or humidity because you need low pressure to have humidity. So the clouds and the yellow is the precipitation and the
green is humidity.
Yeah, so they both go low. And if you lower it, they sort of switch because they're inverse relationship. And the humidity and the precipitation goes high if we lower the barometric pressure.
So if you lower barometric pressure, then you have more clouds, and because of more clouds, more moisture.
Yeah.
Okay.